Okay, continuing on the actual disassembly and maintenance of the SV2500 series, the valve here fully assembled. Here's the valve, which I've already removed the screws as far as pulled them back out. So that's why I alluded to a cordless screwdriver just makes it easier to basically back those screws out. So what you're going to have as you disassemble this is you basically back those 4 screws out. You'll see that there's a little bit of spring tension there, but it's very light, so it's not under an immense amount. But lift that off carefully, and then you'll need to lay that down. The reason you want to lay that off carefully, and I caution everyone, is there's a small spring inside of the plunger, and it's not that the spring will damage or hurt anything, but if the spring actually gets dislodged and falls off, it's very difficult to find. I can tell you from experience on that. Then the next thing you're going to see is this seal disc that's down on the inside here, and that's got rubber bonded on this side and a larger diameter that's bonded for your output port here. Then there's a Teflon ring that goes down on the inside. The purpose of the Teflon ring is as the water's flowing through and around this, it's got turbulence, and we want to avoid the turbulence affecting the washer and causing it to vibrate like that. The final piece of the puzzle is there's a small O-ring right here around the valve base, and that's all there is to the solenoid as far as how it actually, or the pieces and components to it. Now, the problems most frequently is that we receive calls on is my plunger's stuck, I can't, it won't open, it won't close. Typically what happens is this plunger may seize up due to gunk or rust, and it won't come out, and it will be lodged in like that. And that's where like a small screwdriver, a pocket knife, something to work around the edges of it to get it dislodged so that the plunger will actually come out. Now, from time to time, depending on how much moisture you have in your area and so on, you may get a situation where the plunger looks like this and the solenoid looks like this. What you can do with that, and that's where the WD-40 comes in, is you basically use a little bit of WD-40, use a little bit of steel wool, and you basically scrub off the rust like so. And you would do this all the way around the plunger and all the way around the inside of the solenoid. Just take a towel and wipe it off. And then the rust will basically be gone as it is there, and the plunger will return to a state where it can freely move inside and outside of the solenoid. And I'm going to show you the test for that in just a moment. Then the seal disc is the next item that needs care, and this is typically when the valve is repetitively leaking. And what we want to check for there is how well the rubber is actually bonded to the steel. So I use a little paper clip, or you can use like a knife tip or something, and you push along the edge, and right there you see where the paper clip will slide under the rubber. What that does is it allows that rubber to begin to close up this hole, and sometimes this will actually be sucked down into the middle of the hole, but then it can't seal on this surface. Now both sides can become loose over years of extended use. So again, you just push a little bit with the paper clip on that and make sure that that seal disc is either in good shape or it possibly will need to be replaced. Now, in checking the solenoids, and this is where the meter comes into play, that you can do it a couple of ways. If you've got a multimeter, to make sure that the solenoid is good, you set it to the ohms function, which is the omega, or the upside down horseshoe. And then what we want to do is measure the the actual resistance of the coil. And on these 2 amp coils, we should get a value of 6 pop up on the display there. And the simple formula is voltage equals your resistance times your amperage. These are rated at 2 amps. We just had a resistance of 6, so 6 times 2 is 12. Now in this particular coil, when we measure, we're looking for that value of 6.0. It's actually showing 0.2. So that means that this coil is drawing an unlimited amount of amps, which when people say I'm blowing fuses, that's what we're actually looking for, is a bad coil. Now the second way to check a coil is if you've got a power source, and I'm going to use this digital power supply to show you the reactivity of the E-chip coil. But what I want to show you is you use your wires and you take your plunger, your spring, and you put it up inside, and then you go ahead and energize the coil. It draws it up. Now what I want people to take notice is on this E-chip on the display, it's going to pull an amperage value, it's going to draw it up, and then it's going to hold it at about a 10 to 20% less than what the full 2 amps is on this, and it will continually hold it. That's all the power we need to hold it in. Now on a conventional coil, which this one is a standard, what you're going to see is it's going to draw it in, and it's going to hold at that 2 amps. What that does is it generates heat in this coil, and if the coil doesn't have any fluid circulating around the inside here, there's no way, there's less ability to remove some of the heat in here, and they will burn up over time. Now the way to tell the difference between an E-chip and a standard coil is an E-chip is going to have a blue top. A standard coil will have a gray or a black top. So after we've cleaned up and made sure that the plunger is moving freely, that it will be drawn up inside of the valve body, we can basically put everything back together. And the nice thing about these valves is, while this is separate, you can do this right on your sprayer. You don't have to break the plumbing apart. You can simply work from the top side here and leave the plastics in place. So we push this Teflon ring in so that it's basically at or below the output port. It doesn't have to be perfect, but we try and get it in there flat. Put the seal disc back in on top with the small end up. Set the plunger and spring on. Make sure this rubber O-ring is either on the base still, or depending on the amount of time, it may stick to the bottom of the coil. So double check that it didn't stick to the bottom of the coil and that you do have everything in place there, or you will have a leak point. You simply set this down on top, line it up, advance and tighten your 4 screws, and that's the repair and maintenance of a 2500 series valve. With that, we'll go ahead and cut away and come back with how to order components you may need.
Texas Industrial Remcor, quality valves and controls today and tomorrow.